Dear students, in this video I would like to show you how to summarize categorical data using frequency distribution tables or graphs. Then we'll move to summarizing numerical data using frequency distribution tables and graphs. So first of all, let's start with the categorical variables we have in the data frame employee. So employee is a data frame with 200 observations and 25 variables. If you click on the employee data frame, you will see the variables we have in the employee file. Let's choose one of the categorical variable and summarize it. For example, I want to get the summary of the education level variables. I want to know the frequency of each category we have in the education level. So first thing we will do is write the command to calculate the frequency. The command used to calculate the frequency is table. Then we write the data frame name because education level is inside a data frame employee. Then we press $ to go inside the data frame. We have a list of variables. We are interested only to get the summary of the variable education level. Once you click run, you will get the summary or the frequency of each category you have in the variable education level. If I want to present this output as a frequency table, you need to use the command transform before. Then put the table command inside. Now, if you run, you will get your table as a frequency table. In the first column, you have the variable var1, and then in the second column, you have the frequency of each category. Let's save this table as table 1 so that we can work with it later on. So table 1 is equal to the same code we have used before. Run it. You will see that your table 1 is now saved in the environment. If you click on table 1, you'll see that this is your table 1, the one you got it as an output in the console window. Now, next step is normally when we have a frequency table, we need to calculate the relative frequency. So let's assume we have a vector R such that this vector R will take the frequency of each category you have in your education level. So I want to extract the second column from table 1 to get the relative frequency for this. So since the frequency column is inside table 1, I want to divide the frequency because relative frequency means frequency over total frequency. So write table 1, $, click on the frequency column, divide by, again, we need to get the sum of the frequency. So use the command sum to get the total. Again, we have to go to the table 1, $ frequency. So what this code does, it's like a calculator. It will divide the frequency column in each category by the sum of the frequency. So in this way, we will get the relative frequency. Where this relative frequency is saved, it's saved in the environment with the name R, and it is saved as a vector. If you want to see your relative values, you can print it again. You'll see it in the console window. Now, what about percentage frequency? Let's call percentage frequency as P, such that P is equal to R multiplied, that's the formula for P, relative times 100. So your Percentage frequency is saved as a vector in the environment. If you want to see it, you can just type P, run. You will get it as in the console window. Now, next is if, for example, you want to create an angle so that you can draw a pie chart. Normally, we have a code for pie chart, but if you are interested to know how to find the angle, just use your R as a calculator, name as one vector as angle equal to relative times the total angle of a circle is 360. So just run the code. We will have a vector here in the environment with the name angle. We want to see it in your console window. Just type angle. You can see that this is your angles. I want to display all these vectors with table 1. So we can use a command called cbind. Cbind means column bindings. Then take table 1, bind it with R, P, and angle. So all together will be displayed as one table. You can save it if you want as a table 2 in your environment. So that is regarding summarizing your categorical variables as a frequency table. Now let's see what are the graphs used for categorical variables. If I want to display my data using graphs, then bar plot is one of the graphs used for categorical variables. The command for bar plot is bar plot. Inside, you need to use the command table. So this table command, what it does, it will count the frequency of each. So table, then employee, dollar, education level. So this is your graph. In case if you want to change the colors, you can use color, mention the color you want, or just type any numbers from 1 to 4. This what it does. It gives you 4 different colors. 1, 2, 3, 4. Okay. Regarding the pie chart, the command is pie. Again, we use the command table inside. Let me copy this, paste it here. So you can see this is your pie chart. We will not go in detail how to show the percentage and extra. We'll just leave that one as you should know what is the command used for pie chart. Next, we will move, before we move to frequency table for quantitative data, let's see what are the graphs you have for quantitative data. One of the most common graphs or very important graph for quantitative data is histogram, because histogram tells you the distribution of your variable, the distribution of your data. So histogram is used widely for quantitative data. Let's assume that I select one of the variable here. Let's say it's an age. I want to display all this age in a histogram. The command for the histogram is hist. Now you don't need to use the command table inside because you're dealing now with numerical data. Just type the file name, the data frame name, dollar, and choose the variable age. So you are going to get your graphs. So from this graph, you can conclude many things. As for example, you can see that the highest age, the age with the highest frequency is from 30 to 35. Like that, you can conclude many things from the graphs. If you want, for example, to change the color, you can change by writing the color name or just by typing numbers. Okay. This is regarding histogram. What about box plot? Box plot gives you a 5-number summary for your data. So what is the command used for box plot? It's box plot, then employee, variable age. So you can see this is your box plot. What we can conclude from the box plot, we can conclude that this line is the minimum data you have is at this line. This is the 25th percentile. The thick black line is the median or the 50th percentile, or we say it's Q2. This is the 75th percentile or Q3. This is your maximum, and we have one point outside the graph because it's not fitting the graph. It's extremely high, and this point is known as an outlier. If you want to know exactly these values are what, you can use a command called boxplot.stats. So from this output, first of all, stats gives you the 5-number summary, minimum, Q1, Q2, median, Q3, 41, and maximum 57. N tells you that you have 200 observations. Conf means the interval. Your all data are fitting within this interval except 67. So 67 is out, means it's an outlier. We have only one outlier in this data. If you want to draw a horizontal box plot, you just need to use the same command and then put inside your command horizontal equal to true. Run the code. You can see now your graph is a horizontal one. And if you want to change the colors, you can mention any color you want. Run and see the update. Okay. Sorry, we have to write colors here. Now your graph converted to green. What's regarding frequency polygon? Frequency polygon in the x-axis, we use midpoint of a class. And then in the y-axis, we use frequency. Now we don't have a group data, so I'll download a new file where we have our data as a group data. So let's go back to our data frames. We have one data frame called temp. Okay, let me see it. See it here. Yes, this is the file. So it's taking time to download. Let me see if I have downloaded previously. Okay, download. It's taking too much time. See, if you click on the download many times, then you will get a copy of your file. Open the file. Try to ignore or remove the copies. Keep the file name as simple as it is. In this file, you can see you have group data. LCLs mean lower class limits. UCL means upper class limits. So your variables, your data are grouped into 7 classes, and the last column is the frequency. First of all, we need to find the midpoint. So to get the midpoints, let's call your midpoint as midpoint, or we can call it as XM. XM represent midpoint. What is the definition of the midpoints? It takes the lower class limits. Where is the lower class limits? It's inside the data frame temp LCL plus from the temp take the upper and then divide that by 2. This bracket is very important because the whole numerator is divided by 2. Now we have the midpoint. Now you can draw a frequency polygon. Whenever you have a plot where you have X and Y, the command for plotting is plot. Your X-axis is the midpoint. Your Y-axis, you can't type frequency directly because frequency is inside the file temp. Then you will see that your graphs look like this. You have to make it lines. So type inside your command plot, type equal to L. L means line. So now your graphs looks like those dots are connected with a line. Now what's regarding OGIV? OGIV needs in the x-axis the upper class limits, in the y-axis cumulative frequency. So how do you find the cumulative frequency? We create CF. CF is used for cumulative frequency. The command to compute the cumulative frequency is sum. From where we will take, how do you find the cumulative frequency or cumulative sum? We need to use the column of the frequency in the temp file. Okay, so we compute the cumulative frequency. Now you can plot the OGIV. In the x-axis, you have upper class limits. In the y-axis, you have the cumulative frequency. Again, you can see your graphs look like this. In order to make this line, you have to use type equal to L. Okay, this is regarding the OGIV. If you want to display all of these CF and midpoint in the same temp file, you can say cbind, use the temp file, comma, XM is a midpoint, and then CF. So these are your new table. You can update your temp file as well. You can, if you write temp is equal to this new temp, the old temp, bind it with the midpoint with the frequency cumulative, So now you can see your temp is changed with 7 observation and 5 variables. Okay, this is regarding the graphs. What else we can do with this frequency distribution for quantitative data or group data? We can compute the mean also. For example, we know how to find the mean for group data. That should be in the another session, but I can just finish it with this. We know the mean for group data is the sum of the midpoints times the frequency divided by the sum of the frequency. So let's find the mean for group data by applying this formula we learned in the theory class. So midpoint is take the sum of the midpoint. Midpoint is multiplied by frequency. Where these midpoints and frequency are. So they are in the temp file, because already now we updated our temp file. Now we have the midpoint and the frequency. So just type temp, ask the program to take the midpoint from the temp file and multiply it by the frequency from the temp file. Then divide that by the sum of the frequencies, taking it from the temp file again. So doing that, what we'll get? We'll get our mean, which is equal to 114.2. So that is regarding the mean for group data. For more data description, I will explain that one in the next session. Thank you.